So annoying. All right. Okay, so here we go. Did you get these numbers for the first one, right? Pretty easy. 20, 20. Oh, frozen. Let it go. Let it go. On the screen in the class. Okay, boom, right? Boom. Get those, right? Just goes up 5 minutes. You increase. That's actually a good idea when you're working out. Just increase or increase weights by a little bit if you're working out with weights. Just do little increments, and then over time you'll be amazed how much you're doing. But blah 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 blah. Okay, and then well, let's go over here to get this 2, 6, 18, right? Multiply by 3, correct? Okay, there's two different scenarios going on here. Over here on the left, I'm going to use terms that we're going to need for today. There's a common difference. The difference is plus 5 from one event to the next. Whereas this one, there's a common ratio, a common multiplier from one event to the next. All right. And those are two different things. And that's the only two new things today. Now, I told you guys this is what we got to work on. And I'm going to work on myself as well. You know, be more positive, and not yell at the computer when it screws up every single day. Sorry, I'm already going there. And other things. But you need to understand what is it that I learned today, and the most important thing. And it's these two formulas I'm going to show you about these two cases. All right. But anyway, let's check your other work. Did you do this 10 to 60 minutes, right? Kind of annoying though. You had to keep going. You had to keep going through the progression. And then what happens on the 18th? You had to keep going and then keep going through the thing. And you don't have a formula per se. Well, that's what we're going to work on, getting a formula that gets us to that number quicker. All right. And then same thing with the multiplier. And did you get 9,500,000 blah? All right. So yeah, it took a while and that number gets huge and it gets annoying to have to keep multiplying by 3 up to 15 times. So that's our objective today, is to get to that, a formula. And then you could pull the notes up and look at these sentences. We don't have the time. Plus, we got shortened 5 minutes. So the key to these notes will be online shortly. So here's what we have. Can everyone say the word sequence? Sequence. These are sequences, very ordered patterns in numbers, either by an adder or a multiplier. And those are two specific things we're going to work on today, those two types of sequences. When there's a common difference, that's an add or subtract number, or a common ratio, a multiplier of some sort. All right. But here's what we need to understand. I'm going to write some stuff too, even though it was already written here. What does it mean to be discrete? That means, by the way, input, say it. Our input, our domain, it actually is written or typed here for sequences is a whole number. See, because the way it works is I'm looking at terms in a sequence. So the first term I look at is the first term. And then the next term is the second term. But we're going to create formulas where I can plug in 1 to find the first term, plug in 2 to find the second term. So the domain is whole numbers. What is whole numbers? We used to always start math class every single year just with subsets of numbers and what they are. The first set is, nobody cares anymore, but natural numbers. That's 1, then 2. That's how humans first started, just counting objects, quantifying them. So 1, 2, 3, 4. And then historically, nobody cares about this either. The concept of zero in our existence is a relatively new concept. What do I mean by that? You know, it's only 1,000 years old as opposed to 1,000,000 years old as far as the number 1. So zero was a big concept. So that created a whole new subset of numbers called whole numbers. The last one I'll bore you with is, you better have heard the word integers. How many people have heard the word integers? And if you don't raise your hand, get out. Because I've said integers about 5 million times in this class, and I just hurt my leg. I said I was going to be nicer. I won't do that much anymore. But anyway, integers brings up anyone starts with an N. Negative numbers, a high-end concept for human beings. The idea of negative numbers. So whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8. That's what whole numbers are. That's your domain for sequences. That's what it is. Okay, so what does the word discrete mean? I'll talk about that as we move forward. Okay, so they're not connected, so it's nicely in there. Okay, so let's go to arithmetic. That's what our first one is, but that's what we're going to be doing. Can you say the word arithmetic? Can you say the word geometric? Arithmetic has a common difference. That's our first thing for the day, the add 5 minutes. Geometric has a common ratio. The second thing in our bell work, a common multiplier. All right, that has those. So that's the two things we're going to deal with today. So all that's happened right now is just I got your brain hopefully ready. I just have two things to memorize today. All right, now it's formula time, how it works. Okay, now here's how this works recursively. And then we're going to come up with the actual, what's called an explicit definition. Here's how it works in a arithmetic sequence. We have some term and we add some common difference to get to the next term. And that's exactly what you did, up there. So what is a sub 0? A sub 0, okay, I wasn't getting it right. New kinder, Mr. Samuelis. I love this program. You are my favorite. A sub 0 is the initial term, and D is the common difference. So what I want to do is come up with an explicit definition with this new sequence. Okay, this is a recursive definition. This is just what happens to get from one term to the next. I just keep adding, or it could be subtracting, a common difference. First of all, what's the common difference in this sequence when I just see 2, 5, 8, 11? It's 3. Here's what happens, though. You don't care about this, but I kind of screwed this up last year because AP got in my brain and kind of mixed it up a little bit. Anytime you see a list of numbers, that first number in the list is considered to be a sub 1. All right? So that is definitely a sub 1. So 5 is a sub 2. 8 is a sub 3. And then 11 is a sub 4. Okay, input, say it. That means I want an equation that I plug in 4 into and I get 11. So that's how this works too. It's like function notation. So instead of f of 4, we're not going to see that anymore with sequences and series. You're going to see a sub 4. And that just means I want to input 4 into something. So this is sequence notation, not function notation. Didn't really say that last hour. I did, but I didn't write it like that. That's what input is going to look like now, input, output. Okay, let's graph it first. So how do I graph that? I got to memorize these points. So here is 1. That means a sub 1. I plug in 1 for x or n. We're going to be dealing with n more than x. And I got 2 for y. Okay, so that's how it works when you graph these sequences. So when I plugged in, wasn't it 2 or 3? 2 or 3? Okay, because someone was like saying something. I thought I did a mistake. And then isn't a sub 2 comma what? 5, right? 3 more. And then a sub 3, I'm not going to keep writing this. 3 comma 8, and then 4 comma 11. Now, I just told you discrete functions, you're not supposed to connect these. But if I did, what would that picture be, everyone? Linear. So I'm going to explain this way better than I did last year. Not that you care about last year. So for a linear function, what I would really like is the y. Anyone? Intercept. How do I get that y-intercept? I go backwards. How do I go backwards from a sub 1? What would be the next term previous to this? What would I have to do? Add 3 or subtract 3? Subtract. There is that a sub 0. Okay, so a sub 0, you could write this up here. A sub 0 then would be negative 1. Then what I could do is think about this as a line. A line, we actually do this tomorrow. A line is y equals mx plus b. Arithmetic sequences are linear. The m is the common difference. The common difference is 3. X, though, is that common difference. So we're going to write that as D. And then the y-intercept is the initial term, the a sub 0 term. And that's what a sub n is. I should write this as f of x. Like here's function notation, here's sequence notation. Okay? All right, so, but I am going to do something with this. I'm going to show you. All right, let's write this down. And then I could go ahead and write this. Yeah, so it is actually here. I actually went out of order. 3n plus -1. And that's called an explicit definition. What this allows me to do then, to find the 20th term, I don't have to find the first 19, like in the bell work. I can just plug in 20, and I will get that answer. That's different than a recursive definition. What you did in the bell work was like a recursive way of trying to find out future terms. And that's the big deal there. Okay, I'm sorry. That's just I grabbed the first 5 terms. That's why I was off one. But I'm going to do this. And then I hope I climb into your brain. This is why this took a little bit of time. So let's write that first formula down. But let's write it like this. Let's write it with the term a sub 0 plus 3n. That's the one I just wrote, right? That's the one I just wrote. And what is n? That's the what term you're at. So input, say it. So just to double check this, crinkle, drink time. New kinder, Mr. Samuels. Go ahead. It's great. Just fine. Okay. I plug in, well, let's do one that we have here, 1. Okay, so a sub 1, I should get 2. What's 3 times 1, everybody? 3. What's 3 plus -1? 2. I plug in 1, I get 2. That's what should happen. Let's skip to 4, a sub 4. What's 4 times 3? What's 12 plus -1? 11. So a sub 4 is 11. I plugged in 4, I got 11. Simple enough, right? But you know what? You can write 4 more functions for this. And there just happens to be 4 more terms. This one is written in terms of a sub 0. Now let's write it in terms of a sub 1 and not have a brain blow out a brain gasket. 2, well, wait a minute. I'm starting with the first term, which is, watch this, 1 away from the 0 term. 1 away. So I'm 1 common difference off from the beginning. Input, say it. So what should happen is I still should be able to plug in the same numbers and get the same terms out of this. Well, let's look at this first one and get 2. So how do I get 2? 2 is a sub 1. I plug in 1. Hey, everyone, what's 1 minus 1? What's 1 minus 1? What's 0 times 3? What's 0 plus 2? I plugged in 1, I got 2. That's what's supposed to happen. Let's skip to a sub 4. Or I could even plug in a sub 0 and get -1. Great. 0 minus 1 is -1. -1 times 3 is -3. -3 plus 2 is -1. I'm just giving you alternative forms to the same formula. A sub 4, 4 minus 1 is 3. 3 times 3 is 9. 9 plus 2 is 11. I plug in 4, I get 11. This works. You want to get nuts? Let's get nuts. What if I wanted to start at the a sub 2 term, which is 5? Well, then that's 2 off from the beginning. All right, I just want to keep those terms there. Or what if I started with the a sub 3 term? Well, that's 3 off from the beginning. What if I wanted to start with the 4th term? Well, that's 4 off from the beginning. And then what they did, and this is actually the flip math people. I watched the flip math video Friday and thought, all right, I like what they did, but I'm going to do my own notes. But I borrowed this from them just to know that you have options and they all work. All right, if I plug in 4, come on, 4 minus 4 is 0. 0 times 3 is 0. Plus 11, I plug in 4, I get 11, which is the 4th term. But I might want to check is 0. 0 minus 4 is negative 4. Negative 4 times 3 is negative 12. Negative 12 plus 11 is negative 1. I plug in 0, I get negative 1, which is the first term. The other thing I did with my last hour was look at how this formula turns into the first formula if I just simplify. 3n minus 12, we got to be a good distributor, and then a sub n equals, well, 12 plus negative, or negative 12 plus 11 is negative 1. And then notice when I solve that fourth one, I end up with exactly the first one because I should. I solve any one of these for, get it all simplified. I mean, not solved, and it ends up being the initial equation. So it doesn't matter. All right. The reason I went over that, well, let's finish this off. I think there's some other things. Yeah, find the 100th term. Well, that's easy now. A sub 100 equals 3 times a hundo minus 1. You did not have to find the 99th, 98th, 97th. You didn't have to go through the whole progression to get down to the 100th term. That's absurdity. You want a nice formula that gets me there. 299. Okay? All right, and then let's proceed on. It's 9:20, right? Is our ending time, right? 9:20. Now this is a new one. Choose a reset. Resets it. Okay, this is why I went through this, by the way. And this is where your brain needs to be. I need to understand this. You're here, you're watching, you're focusing. Okay? We need to move on from here and walk out the door and say, okay, I got that. It's one thing. It's the stuff we need to work on. All right. Okay, but now that's why I did this thing. So write an equation for a sub n. Well, I have a new situation. It's going down 3. So recognize D. Every term goes down 3 from the first to the next. You could sometimes just think, too, if I have a sub 3, to go backwards, what would I have to do? Not subtract 3, what? Add 3. And you could get down to a sub 0 just by thinking. You did that Friday, didn't you? Remember on the written AP exam? Absolutely. That was great. But we're going to go ahead and do that thing I did up to the right there. I'm going to use the a sub 3 term, and then we know it's plus some common difference, but then I'm 3 off from the beginning. So then that's why that's n minus 3. These must match. I guess another way of saying that, understanding what I just did off to the right of the graph. Okay? And that's maybe a more direct way, and then I could just go ahead and plug in a sub n, put that IED on, you're illegal. The weirdest thing just happened. A random student just said, I'm taking my ID off now. All right. Oh, and then, write the formula. So then I got to plug this in. I was just going to throw it off there. I'm rebooting myself. Okay. All right. So again, why is this a 3? Because you started at the third term. So you're 3 off of the beginning, is how this kind of shakes out here. And then you go ahead and solve. A sub n equals, this is negative 3n. I'll write that first, and hopefully you can handle this. Negative 3 times negative 3 is 9. 9 plus 8 is 17. Where'd you get that 17 from? Okay, negative 3 times negative 3 is 9. 9 plus 8 is 17. And now I can find a sub 12 real fast. A sub 12 equals negative 3 times 12 plus 17. All right. Negative 36 plus 17. Isn't that negative 29 or 19? Right? Anyone? Anyone numerate? Good with their numbers? That's great. Someone just said that's great. Right? Everyone okay so far? Now it's, wait, I don't know if it's something different yet. Okay. And I kind of wanted to get you to understand this then. So what happens if you're given 2 different terms and they're not the first term? All right. What should I do about that? Well, okay, this is formulaic. I really want you to understand it with the red that I have written for the specific question. But how do I find an equation when they give me 2 different terms, the a sub n term and the a sub k term? Well, k is just the kth term in a sequence. Oh, that was supposed to be kth. And that, I don't know if that really works out for here. I want you to understand how I came up with this, what I have down here. Very simple concept. How far, and by the way, it's arithmetic. So you have to read the questions. It's an arithmetic sequence, so that means there's a common difference. So this has got to come out of your head. This is the memorization piece. Okay, I know I have a common difference, so I have a structure here. And the structure is this. Here's my question. How far is the second term to the sixth? How many spaces away? How many spaces away is the second term to the sixth? 4. So they are 4 differences away from the second to the sixth, right? What's 6 minus 2, everyone? 4. That's what this means right here, n minus k, sixth term, second term. There are 4 differences away. So another way you could do it is maybe not this formula, just say, hey, from the second to the sixth, I have some common difference, and there's 4 differences away to get from the second to the sixth. Go right to the 4 right in that spot. And that should make a lot of sense. All right. But now I plug in. Okay, so I know what a sub 2 is. So I can plug in a sub 2, which is 7. And I do know what a sub 6 is, which is 9. So a sub 6 is 9 because of this right here. And a sub 2 is 7. So I replace those names with the actual values. And now look what I have is D. So all I have to do is solve for D. So 4D equals 9 minus 7, which is 2. D equals a half. Okay, but now we got to be careful. What formula do I want to use for a sub 24? It depends. What do you want to start with? A sub 2 or a sub 6? Which one do you have? Someone pick one. 2. I heard someone say 2. So I have to start a sub n equals a sub 2 plus half times n minus 2. I got to plug in, n minus 2 in this position because I started with the second term. That is this right here. All that I did right here. Okay, come on, right there, that one, right? Okay, and that's why we're kind of covering this way. There's another thing you can do, people that are in tune with what I'm talking about. You can revert backwards half twice to get to the a sub 0 term and then write the a sub 0 equation. But I think this is a lot easier. Now I can plug in. Well, hey, come on. If I plug in 24, how far away is a sub 2 from 24? A sub 24, how many spaces? 22. That's what that number means. When I plug in 24 in there, that gives me 22. That means from a sub 2 to a sub 24, I'm 22 differences away. And I keep screwing up. What is a sub 2? I got to plug that in. What is that number? 7. So I accidentally wrote a sub 2 again. I want to write its value, 7 there. Oh, well then I can actually answer this question. Oh, that's easy. Half of 2 is 11. 11 plus 7 is 18. So a sub 24 is 18. So the reason I showed you those 5 different equations, you want to be able to work on the fly on there and be able to know what to plug in. Which formula do I want to use, and so on and so on and so forth. Okay, we're done with arithmetic for now. Now we're going to talk about geometric, your second thing in the bell work when you had a multiplier of 3. Well, then that formula is way different. And we're going to do the same thing. We're going to write 5 different formulas and not prove it because you don't know enough about exponents right now. But this is going to create an exponential scenario. Can everyone say exponential? Okay, and that's tomorrow you get to bring this all together and make some comparisons to different functions. Okay, so here's what it is. And this is in terms of G naught. Did I say the word naught with you guys? Yes, no? Naught is 0. Anyone ever hear that? G naught, G0? Almost like naughty. Like you do 0 rules correctly, you're naughty. Never mind. That's not even true. I just made that up. But I guess not is from some language. I wonder if it's what's the ancient language that all languages that are your Latin. I wonder if it is. Does anyone know? I'm gonna look it up. All right. Okay. Anyway, so some first term times some ratio times raised to the nth. Okay, so let's speed this up. We don't have time for all this rigmarole that I'm talking about here. A sub 1, right? A sub 2, right? A sub 3, right? A sub 4, right? Whenever you see a list of numbers, the first number is always considered the first one. What's the multiplier? What's the multiplier? 2. Okay, so we're going to graph this. I'm going to skip, make this look a little bit better. 1, 2, 3, 4. What's the first one? 3. So the first term is 3. So here's a sub 1. I don't want to call that a sub 1, but I do want to call input 1 there, output 3. And then 2, we're going to skip a couple just to space this out, is comma 6. And then 3, comma 12. 1, 2, 3, 4, 5, 6 more. And then 4, comma another 12, which you know what? It does land on the top. I found that out yesterday, or last hour, I mean. Hey, is that a line? Is that a line, those points? No, you can see the differences start going off the scale as we move from equal input values. I go up by ones on x's, the y's start taking off here. What you're going to find out, you don't know enough about this yet though, is it's exponential. That's why I wanted you to understand this tomorrow. And then actually that's our next component. We're going to really teach you how to graph an exponential graph. And it is going to be input output, and you're going to make some generalizations, and so on and so on and so forth. Okay? All right. Well, not that this is a line, but how do I find the y-intercept? Or how do I find, the y-intercept. How do I go backwards? If it's multiplied by 2, how do I go backwards? Divide by 2. What's 3 divided by 2? 3 halves. So that's what the y-intercept is, 3 halves. So I do want to find a sub 0 because then that's actually my first equation I'm going to write. And I'm going to write that way over here. I don't know why I have it way over here. I think last year I had something else. Let me just restructure this for better. And then 7th hour, I'll do the same. Can't get my mouse going. Don't complain though, Mr. Samulus. New, fresher, happier Mr. Samulus. Okay, so we found my 0 term to be 3 halves. That's my first equation I'm going to write. So it's a sub 0 times r. What is r? What happened from one term to the next? What did I multiply by? 2, and then it's raised to the n. Does that create my terms? It does. When I plug in 0, oh, we got to know this. I better write this down. What is 2 to the 0 power? What is that answer? It's 1. I'm not going to explain. I don't have time for that, but later I'll explain why. Anything to the 0 power is 1. That's supposed to be a general idea that you know walking into my classroom. All right? So anything to the 0 power is 1. So when I plug in 0, 2 to the 0 is 1. 1 times 3 halves is 3 halves. It works. Let's check 4. 2 to the 4th. 2 to the 4th is 16. I don't have time for this. All right? 16. How many times does 2 go into 16? How many times does 2 go into 16? 8. What's 8 times 3? 24. I plugged in 4. I got 24. If you don't understand that, I can't help you. You got to have some numeracy in my class. Or I could start with the first term. This is starting with the 0 term. But if I start with the first term, I'm 1 off of the multiplier. I'm 1 away. So this is if I started with the first term. Let's check this one real quick, and then we're not checking any more from here. We're going to trust it. Okay, let's plug in 0. Oh no, that's going to be tough. Well, you're not going to like this. This is only the few that remember this rule, which you're supposed to. All right, maybe not the math 2 regulars, though. I don't know if you do exponents at all. But if I plug in 0, what's 0 minus 1? What's 0 minus 1? And then you can type this on the calculator if you don't trust crusty old Mr. Samulus. 2 to the negative first is actually going to give you 1/2. That's what a negative exponent means. It's a flip. How many people remember that? When you have a negative exponent, it flips the fraction. All right, so it does work. Half times 3 is 3 halves. What I wanted to do was plug in 0 and get 3 halves, and I did. And then 4, well, 4 minus 3, this is easy. 4 minus 1 is 3. Sorry, 4 minus 1 is 3. 2 to the third is 8. 8 times 3 is 24. So this formula produced G of 4. All right, it produced. And why are we using G? Because geometric. A, arithmetic, but usually for sequences and or all sequences, we use A sub n's. But anyway, G just for geometric. All right, going too long on this. 2, n minus 2, right? 12, I mean, and then 24. So no, I skipped one. Sorry, I skipped one, and then that was a mistake. That's 6, which is the second term. And then the third term is 12. So that's 3 off. So it's n minus 3. Same idea. So I really like what the flip math people did to describe this, because it really helps you having options which formula to use. And gosh, it's easy. 4 minus 4 is 0. 2 to the 0 is 0, or 1. Sorry, 1 times 24 is 24. So when I plug in 4, I still get 24. Now, you'd have to know about negative exponents to get G of 0 correctly. I don't want to get into that real quick. You just trust me. All of these formulas are equivalent. That means they all create the same sequence. They all create A sub 1 through A sub 4 that's listed there validly. And that's what I want you to know. Okay, so we did that. We did that. Now we have a new one. All right, and then we're getting close to 7 minutes. Hopefully tomorrow's a little bit shorter, and then we'll tie all the days together. Okay, but let the sequence be geometric. Stop. Right away, that means I have this. I have G of n equals some term. You know what? We're going to do that thing that I just did up there. We're going to start the sequence at G sub 2, because that's what's given up there, times some r, but now it's going to be to the n minus 2, because I'm starting with the second term in the sequence. And then hopefully this is the easiest, best way to kind of handle this stuff. Then I could just do a substitution. G sub 2 happens to be 64. The ratio is halving, and there's my formula. That's what I'm allowed to do. It's all good. Now to do G sub 5, I plug in 5. G of 5 equals 64 1/2 raised to the 5 minus 2. That's to the third. G sub 5 equals 64. And then how do you take a fraction to the third? What's 1 to the third? What's 1 to the third? What's 1 to the third? 1. What's 2 to the third? Not 6, 8. No one said 6, but some people go into adding instead of multiplying. 2 times 2 is 4. 2 times 4 is 8. And then that actually ends up being 8. 1/8 of 64. 8 times 8 is 64. Mondays. Somebody's got a case of the Mondays. Anyone ever see Office Space? All right, anyway. Everyone should see that movie. It's how it really works in the real world, working in an office with crazy humans. Anyway. Okay, this is kind of just what happened. But I can explain this. G of n equals G of k times r raised to the n minus k. This just says how far away these things are. Like here we go. Let's think about this in the sequence. How far away is G sub 1 to G sub 5? How many iterations of the ratio? 4. So the exponent's going to be 4. All right. So here's what we're going to do. We're going to write this like this. We're gonna create this formula starting from G sub 5. And then from G sub 1, some r, but it's raised to the 5 minus 1 power. That's what this means in here. That's what that n minus k means. 5 minus 1 is 4 away. And then what I'll be able to do is find that r value. This is what I missed with the other class, and this is a little bit challenging. So tomorrow I have to start with this. So maybe for your homework, do as much as you can today. I'll clean this up tomorrow and then move into the shorter notes that are scheduled for tomorrow. Then you should be able to put it all together. But this gets a little bit crazy here. So G sub 5 is negative 512. And G sub 1 is negative 2. Here's the idea. I have to multiply negative 2 by an R 4 times in order to get to negative 512. And that should make sense. Why? Sorry. Reading, it's geometric, so I automatically have an R situation. So it's this formula I have to access from my brain. This is like your job. This is your responsibility for understanding. Okay, so I hear geometric, it's an R thing, so I have to set this up. Now here's the problem. How do I solve this equation? This may be new. And then math 2 regulars, we might have to wait for some time to get a real good feel for this. But R to the 4th, I know equals 256. My math 3ers and math 2 honors. How do I solve for R to the 4th? What do I do to both sides? You don't remember from last year? You don't take the square root of both sides. You take the 4th root of both sides. We got to get our calculator out. Okay? And then there's another problem for this. Oh, I actually am going to have to write this only in radical form because you don't know enough about this. So what I have to do, not square root both sides, you have to do what's called 4th rooting both sides. And now this is going to scare you, and I think this is probably a little too challenging right now for the notes. We probably jumped a little ahead. These are the things we'll have to work on. This is high-level stuff here, or levels of stuff. Uh-oh. Okay, I thought something was wrong there. Okay, so second quit, and I'm going to go to the calculator here. Where's the 4th root button? Hit the math button. See that in red there? Actually, you see it. You see the cube root button, right? See that one right here? It's that 5th one. It's the X root button. But here's how I got to do it. Okay, I'll access it, but then I'll show you what you got to do. All right. Anyone that has a cheaper, no, not cheaper, an older calculator, you don't get that choice of making that 4 in that subscript. But this will work. Or you type 4 first, then you hit the math button, and then hit 5. And then it comes up right away in that 4 position. Anyone with a TI 83 or 83 plus, you'll have an X root button as long as the 4 is first, you're good. But here's a problem. And then we'll finish this off here. You know a negative times a negative times a negative times a negative is actually a positive, right? So it's actually plus minus 4, just like when we were square rooting. There's always a plus minus answer. The bell's about to ring. I think you can do most of the homework. Anything that's tough like this, we might have to skip, and I'll continue this tomorrow. I won't even finish this video because I think this is a good spot to stop anyway. Okay, so main thing, those 2 equations, get those down in your head. Geometric and arithmetic.